What if the future of electric cars didn't change because of a battery, but because of something almost nobody was paying attention to? A few months ago, the CEO of Mercedes stood in front of the world and calmly confirmed something that had only existed as whispers in engineering circles. The YASA axial flux motor is real. Not a concept. Not a prototype. Real. And in that moment, the balance of power in the EV world may have quietly shifted. Because if this motor performs the way Mercedes claims, it doesn't just improve electric cars. It challenges the foundation Tesla built its empire on. For years, the electric revolution has had a clear hero. Tesla proved EVs could be fast, desirable, even dominant between 2010 and 2015. While most legacy automakers hesitated, Tesla moved loudly and confidently. Bigger batteries, faster acceleration, software updates. Meanwhile, Mercedes watched carefully, and instead of competing headline for headline, they made a different decision, one that wouldn't make noise for almost a decade. In 2019, Mercedes acquired a relatively unknown British engineering company called YASA. At the time, it looked like a normal business deal. A luxury automaker buying a niche motor startup, but inside that deal was something unusual, a different way of building electric motors. Not better batteries, not new software, a different core. And Mercedes didn't talk about it. No bold promises, no flashy launch events, just years of quiet funding, engineering, and testing. Because here's what most people don't realize. Electric cars don't just compete on battery size. They compete on how efficiently they turn electricity into motion. And that's where this story starts to get uncomfortable for everyone else in the industry. Traditional EV motors, the kind used by most companies today, are called radial flux motors. They're cylindrical, thick, reliable, but heavy. The YASA motor uses something called axial flux design. Instead of a cylinder, imagine two thin discs facing each other, flat, compact, almost deceptively simple. That design changes how magnetic force flows through the motor. And that small shift, the direction of magnetic flux, may be more important than any battery breakthrough we've seen in years. But this only matters once you see what happens when you put it inside a car. Axial flux motors are significantly lighter and more compact for the same power output. That means less weight, less wasted space, and more torque density. Torque, the force that pushes you back into your seat, arrives instantly in electric cars. But with axial flux, that force can be stronger and more immediate. Not because the battery is bigger, but because the motor wastes less energy turning electricity into motion, less heat, less loss, more output. And here's the quiet advantage nobody talks about yet. Efficiency compounds. If the motor wastes less energy as heat, the battery doesn't have to work as hard. That can translate into more range without increasing battery size. Or smaller batteries with the same range. Both scenarios change cost structures. And cost structures change markets. Now imagine what happens if Mercedes integrates this into its high-performance AMG models first. A lighter motor, higher torque, faster leaned-out e-buy. The headlines would focus on speed, but underneath that, something deeper would be happening. Tesla's current dominance relies heavily on battery innovation and software optimization. Their motor architecture hasn't radically shifted in years. It works, it's proven, but it's conventional radial flux technology. If axial flux scales, and that's a big if, Tesla wouldn't just be competing on software anymore. They'd be reacting to a structural hardware leap. And reacting is very different from leading. BYD faces a different problem. Their strength is battery production, efficiency, and scale, especially in China. But if motor efficiency becomes the next battlefield, battery advantage alone may not be enough. And Toyota, still investing heavily in hybrids and hydrogen, could find itself pressured from a direction it didn't prioritize. But before we call this a revolution, there's something we need to slow down and consider. Manufacturing axial flux motors are harder to build. They require precise magnet placement. They rely on rare earth materials like neodymium. Scaling production to hundreds of thousands or millions of units isn't trivial. Many technologies look unstoppable in labs and struggle in factories. The real test won't be performance specs. It will be cost, reliability, and supply chain stability. And this is where the story becomes less about speed and more about timing. Mercedes didn't rush this announcement. They waited, tested, simulated thousands of driving hours. Because entering too early with unfinished tech would invite ridicule. Enter too late, and you're irrelevant. Announce at the exact moment confidence is highest, and you control the narrative. Investors noticed. Markets reacted. Not explosively, but carefully. Because even the possibility of a more efficient motor platform forces analysts to reconsider long-term EV margins. Governments pushing for stricter emissions targets might lean harder into subsidies for high-efficiency electric platforms. Oil demand projections could shift slightly faster. These are small ripples, but in global markets, ripples compound. Still, we haven't answered the real question. Does this motor truly change the game? Or is it simply a powerful, incremental improvement wrapped in strategic timing? History gives us both possibilities. The auto industry has seen revolutionary announcements fade under manufacturing pressure. But it has also seen quiet engineering shifts redefine decades, like the move from carburetors to fuel injection. At first, subtle, eventually universal. If axial flux becomes mainstream after 2030, we may look back at this moment as the beginning of a hardware transition phase in EV. Not dramatic, not explosive, but foundational. A shift where customers stop asking only about battery range and start asking what motor sits inside the car. And that might be the real disruption. Because if the heart of an electric vehicle becomes the differentiator, not the battery, not the touchscreen, not the brand, then the entire competitive map changes. The leaders today may still lead. Or they may find themselves defending ground they once assumed was secure. So here's the perspective shift. Maybe this isn't about Mercedes beating Tesla. Maybe it's about whether the next decade of EV innovation will be driven by louder marketing or quieter engineering. And if the biggest breakthroughs happen in silence, how many of them are already underway right now, waiting for the right moment to be announced? Because here's the part most headlines won't explore. If Mercedes is right, this isn't a product upgrade. It's a philosophy shift. For over a decade, the EV race has been obsessed with batteries. Bigger packs, faster charging, better chemistry. Entire supply chains reorganized around lithium. Countries competing for mining rights. Billions invested into gigafactories. And while everyone was focused on storing more electricity, Mercedes appears to have asked a quieter question. What if we simply waste less of it? That question sounds small, but in engineering, small efficiencies compound into structural advantages. A motor that runs cooler doesn't just improve range. It reduces stress on components. It allows tighter packaging. It changes thermal management design that can reduce cooling system weight, which further reduces total vehicle mass, which further improves efficiency. Suddenly, one design choice cascades through the entire vehicle architecture. But this only becomes disruptive if it scales. Right now, axial flux motors are expensive to produce at volume. The precision required in magnet alignment and the demand for rare earth materials introduce supply chain pressure. And that's where reality steps in. Because Tesla didn't win simply by having good technology. Tesla won by scaling faster than anyone else. Manufacturing is where revolutions either solidify or stall. Mercedes knows this. That's why they're reportedly starting with high-performance and luxury segments. Lower volume, higher margins, controlled rollout. If something fails, it fails quietly. If it succeeds, it builds prestige. And prestige builds demand. But here's where things get interesting. If AMG models begin outperforming Tesla's fastest vehicles, not just matching them, perception shifts. Tesla has long owned the narrative of electric performance. The Model S Plaid redefined expectations. Instant torque. Record-breaking acceleration. But if Mercedes delivers similar or superior numbers with a fundamentally different motor architecture, Tesla can't respond with software updates alone. They would have to redesign hardware. And hardware redesigns are slow. Meanwhile, Chinese manufacturers like BYD operate on a different axis: cost efficiency and vertical integration. If axial flux technology proves adaptable to mass-market vehicles, China's manufacturing ecosystem could adopt and scale it aggressively. That would compress timelines dramatically. What begins as a premium European innovation could become a cost-efficient global standard, faster than expected. But again, that depends on materials. Rare earth magnets are heavily concentrated in certain regions. Geopolitics matters. Trade policies matter. recycling technologies matter. The more the industry leans into high-performance, magnet-based motors, the more it exposes itself to supply volatility. So this isn't just an engineering story, it's an economic one. And here's the deeper layer most people haven't considered yet. If motors become dramatically more efficient, battery sizes may plateau. That changes demand curves for lithium. That affects mining investments.